Hey, hi guys, good morning.
Good morning, sir.
Morning.
All right, so today we'll discuss about another neural networks, which is known as recurrent neural networks, and the use case on the CNN. Vikrant will cover. Okay, so I will cover the concepts and then he'll cover the use case. So, so today let's discuss about this recurrent neural network. What exactly these networks are all about, and how can we utilize this? That's something we will understand today. Okay, so as the name suggests, so these are networks. So so here there would be a multiple networks. Okay, so in CNN we have seen that it is one single convoluted neural networks where we have uh, different kinds of layers for image processing, and then we have that fully connected layer, which is a typical ANN kind of a network, right? So here in this recurrent neural networks, we have a different layers again, but every layer will have a independent neural artificial ANN kind of a network, and these all networks will be interconnected with each other in a sequence. Okay, so every network will try to bring out some more insights one after the another. Okay, the output of one network will be the input of another network, and that's how it will try to extract a lot of hidden insights and patterns from the data. Now you must be observing now. We talked about a simple algorithms like linear regression, which was just equation based models. Then after that, we have seen how these algorithms have been evolved, and we talked about some sophisticated algorithms like SVM, random forest, and all those things. And now this neural networks is altogether a different ball game. It's a different subject altogether. And here, primarily, the whole intent is to mine the huge, large data sets. And when you have to deal with large data sets with several columns, several rows, then you need to have some uh, state of the art kind of algorithms which can go deep into the data, understand the patterns, understand the relationship, and mine the information out of that data. Just give me a moment. Sorry, guys. Okay, so let's understand what is this recurrent neural network. So if you look at this structure, uh, here we have input. Okay, so this is like a typical any network. Uh, Neural networks will have typically three layers. One we have input, another we have hidden layer, and then the output, right? But how this RNN is different is here in every hidden layer, this hidden layers in itself would be a small network, okay? Where in each of these layers, separate input can be passed. One is like the input, okay, will be considered at this particular layer. But here we have the provision that in between these hidden layers, which could be a network in itself, can also take some input. Now, why is it important? So RNN typically is used when we have to pass the context, okay, along with the previous or along with the input. So for example, if I'm saying he is a good dash, okay, and we want this to be filled up. So you cannot able to decide what to fill in this particular blank until unless you have this information, whether it is he or she. If it is he, then you will fill a boy or a man, or if she, you will fill it as a girl or a woman. Okay. So here, now this is a sequence, right? Here, all these words needs to be passed in a sequence. So to predict the next word or to predict what event may occur, if some sequence of events have occurred, okay, based on that, if you have to predict what could occur, then here and then in those kind of scenarios, RNN would be a best algorithm to use. In all other algorithms, you have seen that there is no sequence of data what we are passing, right? So there is no time factor involved in whatever use cases we have discussed. So if there is a sequence, if there is a time attached to the events, then the RNN is the best algorithm to choose. So here, if I'm passing he, okay, so this would be the input, the first event. And now based on that, some uh, weights and biases will be calculated, and then it will move forward. Then it will add another input, which is uh, here in the text, in the NLP, these kind of words, preposition, conjunctions, these kind of words will be discarded. Only the keywords will be passed. So here the next word would be good. So here this new input is getting included. Along with that, the previous context is also intact. Okay. So it will understand there is a event before good, which is a word he is there in the sentence. And based on that, it will again update the weights. Again, it will move forward. Then again, the third word will be added. Then again, the weights will be decided. And this context is coming in the sequence. Okay, the first word is he, then second is the good, then third is, whatever word comes in the sentence. And based on the sequence of these words, it will generate the fourth word. So not only in the text kind of a scenario, but even in any kind of time series. Time series is a data, is a data structure where you will have a date column and you will have some values attached to that particular date. For example, sales. Okay, so January 1st, what was the sales? January 2nd, what was the sales? Okay, so like that, there would be a time factor and there would be a values. So even in the uh, kind of a scenario where you need to forecast the future values. So for example, you have 10 years of data. Now, based on the 10 years of data, you would like to forecast the next month's sales. So you pass this 10 years data, okay, and in this network, uh, all the sales which has happened in the past, all that historical data will be given to this network one after the another in the sequence. And here the sequence matters, right? So you cannot put January 2 on the top and January 1 below. So in the January 1, let's suppose the sales was 1,000. and then it was 1200. Okay, so it will understand how the sales are changing over the period of time. So it will consider the context. It will consider the past historical patterns, and every time it will take the next input along with the historical patterns to understand how the things are changing. And that kind of a learning it will learn, it will do, with based on the data, and based on that learning, it will predict the future sales. Okay, so here again in each of these network there would be an activation functions. The weights will be decided, and accordingly those in that information will be combined with the historical data or the past data, and the updated weights will be passed to the subsequent layer. Okay, so if you observe that in if this is the whole hidden layer, okay, the input of previous layer is getting passed to the subsequent layers. Okay, and if you consider this as a one single hidden network, so this will be recurrent neural network represents like this. Okay. So the output of one is becoming the input of another layer. So that's the reason it is called as a recurrent neural network, and it is shown like this. Okay. So this could be as many layers as you want, that many based on the input size, that many number of layers, it will automatically, it will consider. Okay, so this is your RNN. So typical in a short form, the architecture looks like this, and it shows like a feedback kind of a loop. Okay, it's a loop where the output of one layer will become the input of another layer. So this is how it will, and it is all sequenced. Uh, when you compare with the typical ANN network, the only difference here is in ANN, the entire input we are passing at once in the input layer. We are not passing one at a time. Okay, we are passing all at once. So in the ANN, this particular input layer will consider all the columns at once. Okay, all the input, but it need not to be in sequence. So you can randomly pass the data, so it doesn't affect that ANN network, because their time is not a factor which we are considering there. But here in the recurrent neural network, the first input will take only the first event. Okay, and after that, other events will, in a sequence, will be given in each of the layers in this RNN. Okay, just like this. Okay, every time, a separate input will be passed to this hidden layers. So if you unfold this neural network, so here the time is important. So what was the event at t minus one? Okay, so t minus, let's suppose the current time is t. Okay, so you have passed t minus one input, the weights will be updated, and it will give some output. Okay, either you can read the output, what would be the output based on this input at each layer, at this layer, or else you can pass this output to the subsequent layer. Now, the output of this layer will become the input to this layer, and also whatever event has occurred at time t, that will also become an input. So for example, this is yesterday's stock price. Okay, this is today's stock price, and this is tomorrow's stock price. Okay, so not tomorrow. Okay, let's suppose we have information about tomorrow. Okay, so day after tomorrow, what would be the price? That would be the output. Okay, here. So in this RNN neural networks, recurrent neural networks can be used for text for NLP, because they are also the sequence is important, sequence of words are important, and it is also used for forecasting kind of a problem. Okay, where again, you have a time, and there also the sequence is important, how the sales have changed over the period of time, how the values have changed over the period of time. So there is also sequence matters. So you have to understand, when you are qualifying any use case for RNN, you have to understand whether the data is in sequence or not. If it is in chronological order and the sequence matters, then you can go and utilize this recurrent neural networks. Otherwise, it is not required. Okay, otherwise you can go with the traditional neural networks. But see, and this was the first invention what has happened in this space for a sequential data. But over the period of time, when people started consuming this or using this particular algorithm for their use case, what they observed is for the larger data set, they were facing some problem. One such problem was vanishing gradient problem. What is this vanishing gradient problem? You know about neural networks, how does it work, right? So firstly, it randomly assigns the weights, okay, and it processes that particular network, and the output is calculated. And this output will be compared with the actual values. I'm talking about the learning process or the training process of this neural network. And when the particular output is compared with the actual values, the errors are calculated. And that errors will again passed from right to left, okay, in this particular neural network. Based on that information, the weights will further gets updated, okay, and that happens with the help of gradient descent. So if you have more layers, then what happens is the gradient, basically the slope uh, of this gradient descent or the learning rate, as it moves from right to left, the gradient becomes so low that the weights in the initial layers will take a lot of time to reach to the optimal values. So for example, learning rate is 0.01 here. Okay, so based on this learning rate, these weights will get updated. So these weights can be updated quickly because you have a decent learning rate. It is neither too small nor too high. And you know, right, what is optimal, why we need optimal learning rate. So based on that, these weights will be updated. Now again, here when it comes, the learning rate decreases. Okay, so if you look at the mathematics, how it happens is here it is like 0.01. Here the learning rate will become 0.01 whole square. Here it will become 0.01 cube. So the values are decreasing, and the values as it decreases, this learning rate, it will take more time, to reach to the optimal values, to update the weights to the optimal values. Now, this is the problem which people faced when they were using the recurrent neural networks, and this is called as vanishing gradient problem. Okay, so here it is. The gradient almost vanishes as we move towards the starting layers, and it becomes difficult to train these layers. So from the last till the beginning, when this back propagation process works, so by the time it reaches to the starting layers, the gradient almost get vanishing. For example, let's suppose I put 0.01 raised to the power 10. So it would be very, very small values, right? It would be 0.000, something like that. Okay, so it's a very small, is it almost equal to zero. So that's what they are saying. It almost vanishes as we move towards the starting layers, and that's how it becomes very difficult to update these weights. So that is the problem which may face when we are going with the recurrent neural networks. In a traditional artificial neural networks, it happens at once because here the problem is that these inputs are being passed at every layer. So in every layer, the gradient descent has to work in a uh, independently as a separate network. So that's the reason this vanishing gradient is a problem in recurrent neural network, but in typical ANN, there also we have multiple hidden layers. There we will not face those kind of issues because all the input is getting passed at the initial layer only, and all the weights will be updated at once. Okay. But here for every input, the weights have to be updated, and that effect we have to see on the overall output. So that's the reason. The way they have structured is the every time this learning rate will be based on the previous layer, and that's how the learning rate will gradually decreases as we move towards the starting layer. So just for your understanding, think that in this RNN, uh, the gradient, okay, because of the learning rate decreases uh, from the end layers to the starting layers. So that was a major problem. So for that, what they have done is researchers, they have come up with altogether a different kind of network, which we call as long-term short-term memory network. In short, we call as LSTMs. So these are also a kind of recurrent neural networks, but these are not like a traditional network what we have seen. So here they have made some modification, and this network is also meant to handle a sequential data. Okay. Now instead of wherever people were using recurrent neural networks, they started replacing that algorithm with this LSTMs. So this LSTM has multiple advantage. One is like it does not have that problem of vanishing gradient, and the second is it is faster, okay, and it is much more efficient. You will understand that what all components in this LSTMs are there. It is quite efficient and effective, and it can scale to large data sets. Now, just relate to our human brains. Okay, if we also need to analyze some kind of sequence of events, how we basically do? We should also have a long-term memory and the short-term memory, okay, to take the better decisions. Long-term memory means what has happened. For example, I'm doing a stock trading, okay, and I'm following one particular stock. I should understand how this particular stock overall performed over the period of time. Initially, what was the price, how it fluctuated, and then how it is being getting traded in a recent couple of months or weeks. I need to have a proper long-term memory and the short-term memory so that I can get a complete picture about the entire pattern of uh, you know change in the values of stock prices, and based on that only I can take a better decisions in our real life, in our personal life also. If we have that kind of memory where we remember everything what has happened in the past, and we also have a good short-term memory, we can definitely can take a better decision because we will have a context with us. Okay, what may happen, what may not happen, how things are changing, everything. Okay, so that would be, and even our learning could be better because we can relate things. It's all about relating, right? If you have a long term memory, and if any incidents has occurred in a recent past, you can able to relate it well. And if you can relate the events properly, your understanding about that particular problem would be better. Okay. And you can take a wise decision. So, based on that, people have come up with this network where the sequence is important, where the network needs to remember what has happened in the past and what is happening now so that it can take a better decision. So, so here it's all about mathematics. So I will share you the link, one link, okay, which will give you a deeper explanation about this. But again, as I mentioned, if you want to understand mathematics, do it in your leisure time because it's a very complex mathematics, and nobody bothers or nobody expect you to understand the complete mathematics around it. But you should understand how to utilize this particular tool to solve the problem. Okay. So here the information flows through a mechanism known as cell states. Okay. So here you have to relate uh, to to a mechanism where you just think about it, like if you are passing certain information, this network will understand whether this information is useful or not. Okay, if it is useful, then it will pass it, okay, to the further network. If it is not useful, it will just discard that particular information. And all these information flow will be controlled by these cell states, or we call it as gates. Okay. So, um, okay, let's take this example and then I will show you one architecture and then you can relate it. Now, if you want to make some stock predictions, and stock prediction is very, very hard to predict. If anybody understand how to predict the stock, he will become a millionaire, right? So it's a one thing where continuously research is being happening, because lot of factors influences the stock prices. It could be people, social factors, it could be economical, it could be political, it could be anything. Okay. Uh, so all that factors to examine, and there would be internal factors in the company itself. How the company is running. What is the debt, what is the business they are doing, what kind of uh, uh, advancement the company is making. So all that factors are important. So these wealth managers, these investment bankers, all those things, they spend a lot of time in understanding all these factors to select the best stocks. Okay, and based on that, they will prepare the portfolio of their customers. So in the stock prediction, one major thing is like all there would be multiple input factors, and the second is a lot of historical data you need to analyze to understand how these stock prices are changing over the period of time. So let's let's understand. What are the important things if you have to make the predictions you will consider. One is like the trend that the stock has been following in the previous day. It could be downwards or it could be uptrend. Then the price of the stock on the previous day, because many traders compare the stock previous day prices. So previous recent information is always important about the stock. Okay, if anybody is into trading. So if you examine the previous few days, how the trend is. Okay, if slowly the stock prices is changing, so that pattern will stay for some time. And these people who are into this particular business, they understand that trend, and they instruct that at this is the right time. Here this price is slowly increasing, and it will continue for further few days, so it is the right time to buy the stock. And as soon as it reaches certain peak, and from there again the downfall will happen, and again there they will say that it is right time to sell the stock. Okay, so the overall trend is important, the previous pattern is important for the in the recent days, and the factors that can affect the price of the stock for today. Okay, this can be a new company policy being criticized, or drop in the company's profit, or unexpected change in the senior leadership. So, as I mentioned, there could be a lot of factors. If there is any change inside the company, and even any major events are occurring outside the company, or like in the country, or overall, for example, pandemic, it's a big event has occurred in overall in the world. So that has also impacted the stock prices. So overall trend, okay, the previous trend, and what is happening outside, all these factors are important to examine or analyze to predict the stock. Now, here in this LSTM, what all information dependencies this network may have to predict the future stock. That is the information that was present in the memory after the previous time step. Okay, the previous hidden state, this will be the same as the output of the previous cell, and the new information that is being fed in that particular moment. So what is there previous in the previous layer, whatever the output, that would be the input, and at that particular time stamp, whatever the event has occurred, that information also will be fed to this particular network in that particular time step. So if you have seen this, the output of the previous and the input at that particular time period will become the input to this particular hidden layer. So this is the information dependencies what the network will have at every layer. Okay. Now I quickly move to this particular network. This is a very complicated kind of a network. By looking at this, people may get scared, but we will understand. One one by one, each of these components so that we can get a complete understanding about this LSTMs. So here also, if you have seen that all these blocks are connected sequentially, okay, and these are known as memory blocks or cells. Now, again, you have to relate with our human brains. See, at this moment, what has happened in the past. From, let's suppose I take a small time period. For example, the class started at 9. From 9 till this time, whatever has happened, that is there in your memory. Now, at this current time, whatever I'm speaking, that is also being fed to your brain, right? So that is also getting. So whatever I've covered from 9 o'clock till date, that something is staying in your memory, and that current information which I'm feeding, that is also getting into your memory, and then you are in some processing is happening and the context is being set, and you are understanding that this whole uh, discussion is happening around recurrent neural networks, right? So here, one single block may not able to process this entire data. So here we will have a multiple blocks, and these blocks have been differentiated based on the timestamp. So whatever timestamp you have considered in your data, that many cell state it will keep on adding by itself. Okay, you need not to go and declare that. So at this time period, first time period, that some input has been passed. Here, some processing will happen, some output will come out. That output will be passed to the subsequent block. Okay, you can call it as a layer, but in LSTM we call it as a block. Okay, and here we have a kind of some network inside this block. So this is called as cells. In our brain also, we have multiple neurons, which are nothing but the cells, right? So it has a capability of even storing certain memory. So our brain is a combination of this LSTM, this ANN, because we can also understand the sequential data, we can also understand images, we can also understand text, we can also process the structured data. So our brain is much more complicated. You can think about this. Our brain is a combination of all these kind of networks together. Okay, and for every action and reaction of humans, they have come up with different kinds of neural networks. And based on the use case, based on the problem statement in hand, we have to decide which neural network would be apt, for solving that particular problem. Now, these memory blocks are responsible for remembering things, for manipulations, okay, and even if we have to forget, or if certain information is not important, that would be also managed in this particular blocks, and that all will be controlled by these gates. Okay. Again, guys, just give me a moment. Okay, so now in this memory blocks, all that information is getting shared, right? So it is coming from the previous block. Okay, the new input is also getting passed. So some level of processing or manipulation is required in each of the block. It is not like, it will just take the previous output and the input and then pass it to the subsequent. Here, again, the contextualization will be done. Okay, here it will understand whether this particular input is important in this particular block. If yes, then it will take it. Otherwise, it will discard. It will also understand that this particular time, okay, whether the context was important or not. So as I mentioned, he is a good, right. So for, let's suppose for predicting this, do we require this? Maybe not, right? So this information is not relevant for this, okay, for predicting this particular word. So is for this, is it important? Maybe not. This is a separate word which is coming, and for this to predict these words, the previous words are not required. So you can just directly take it as an input. So this particular, the memory pipeline, so which is giving me what all events have occurred in the past may not be required in this block, okay, for this time period. But for this word, the history is important. So so it will understand by itself when you pass the data because it will run multiple times, right? Front and back. So when it is updating the weights and all those things, it will understand where to give higher weightage, where the weights are not required. If the information is not important, the weights will be zero. So that particular input is probably is not required, for making the final prediction. So all that thing will be controlled inside this particular blocks by these gates. So gates, you can think about like, for example, the water is stored in the tank, okay, in the water tank, and you have to supply that water to individual houses, okay. So what you will put there would be a gates, a taps, right, which you will on it when the water, then the water will flow. If you close it, the water will not flow. So here to control this kind of information in this blocks or memory blocks, there are multiple gates. Okay. So there is one forget gate. If this gate is closed, then the information will not pass. And in this particular block, all the information which is there of the past, this in this particular block, all that information will be forget. Okay, so it will not use that. So it will forget all that information because it is not important in this particular block for this particular time period. Now, this forget gate is responsible for removing the information from the cell state. The information that is no longer required for the LSTM to understand things or the information that is less important will be removed via multiplication of a filter. So this is that particular gate. Okay. So it is just like 1 or 0. So if it is multiplied by 1, then this gate is considered as open and this information will be used to manipulate this particular information. If it is 0, then this information will not pass. So this we also called as memory pipeline. Okay. Now this is required to optimize the performance of LSTM network. See, all the information, if you take a non-important information also, if you process it, firstly, it will take a lot of time, okay, unnecessarily, uh, you know, to process and to compute or to analyze that information will unnecessarily will lose out time and efforts. And even the performance of this neural network will be low, if you are, and the major disadvantage is your network may get overfitted that we have understood, right? So if you consume all the information, which is even if it is not relevant, your model may learn too much and it may lead to an overfitting problem. So here, these things will already taken care in this LSTM network, and based on this gate, and this called as forget gate. So whatever memory from the past blocks is passing through this particular pipeline will be controlled by this forget gate. So there's the reason this gate has been called as forget gate, because if you uh, if this gate is closed, then all the information, the past information will be lost. Okay, and that is something like you have forgot all those past information. Okay, so this is about forget gate. Now, second, we have the input gate. Input gate is this. So here, whatever information you are passing at a particular time period, that input, okay, will be controlled by this particular input gate. This is that input gate, this cross. Okay. So firstly, this input needs to be added as is to the memory. So whatever the past events has occurred in that particular events, this particular event will get added in a sequence so that it will get added. And this is a sigmoid sigma where some transformations on this data will happen and then it will go and add to that. Now, here also some transformation you can consider as scaling or some minimal transformations will be done on this data and this will be passed to this particular gate. If this gate is open, it will go and it will get added. Okay, after manipulation, it will get added to this again memory pipeline. Okay, and this is the activation function, tanh. Okay, it is like by default in LSTM, they are using tanh. Tanh is also one of the activation function. It will get added. Now, after processing this, okay, then again the output is also generated. So now this output is controlled by this output gate. Okay, whether this output needs to be sent to the adjacent uh, block or not. Okay, for that particular block, whether the output of the previous cell is important or not, that will be controlled by this particular gate. So typically, what you need to understand is if somebody is asking about LSTM, you have to say that it is a combination of multiple memory blocks or the cells, and in each of the cells, there are three gates. One is like forget gate, second is the input gate, and the third is the output gate. With the forget gate, all the past memory, all the past events information, it will be controlled uh, uh, through this forget gate. If all that information is important, then all that information will be carried forward. If it is not, then it will be discarded, and that will be controlled by this forget gate. Now there is an input gate. At every timestamp, at every cell block, a new input will be fed to the network. And if that input is relevant, if it is important, then again that will be passed. Otherwise, that will be also discarded, and that is controlled by input gate. And in every block, the output is passed to the previous cell. Okay. So for example here, so this is my memory and all these gates are known as forget gates. So it is a memory. Okay. And this is just the output of this block, which is getting passed as an input to this particular block. Okay. Now, if this thing needs to be, this is just like previous layer. In the previous timestamp, what has occurred, that's something, okay, we are passing it to the current block. Whether the previous information of the block is important or not, that will be controlled by this output gate. If it is important, then it will be passed. Otherwise, it will be not passed to this particular block. So now this mechanism works in every block, memory block, and every memory block is attached to a particular timestamp. So with this gates and with these blocks, this whole network will understand what values at what timestamp is important to consider, what information at each of these timestamp is important to process, and that's how it will understand the context and it will understand what is happening over the period of time, and it will able to give the better predictions. Now here you see that there is no gradient descent kind of scenarios here. Okay, so here every block is independent. Okay, independent in the sense uh, here, this is like memory. Okay, this is memory will be there, this input will be there. And here the weights will be updated to understand whether the output of this memory block would be relevant to the overall predictions or not. And here every block will update the weights based on what is the impact on the overall output. And that's how these gates will be controlled. So they will close this gate and it will close the gate and it will see that is there any impact on the overall output. If not, then okay, it will either close it or open it based on how where the accuracy is high. So typically the LSTM is has multiple such kind of layers. Okay, where just imagine these are all blocks. Okay, cell blocks which we are talking about, right? And at every timestamp there is an input which is being fed to each of this block. And in each of this block there is an output coming out of it, and this the same output is going to the adjacent block, right? So here just think about it like some of the blocks may not be relevant. Okay, that information in that particular block as an input or whatever the output coming from that particular block may not be relevant, so those blocks may called as dormant blocks. So some of the blocks would be very important. For example, he's a good boy. He's and A is not relevant to make any predictions for in that particular blank cell. So those words would be irrelevant. Those would be of lesser importance. But he is very important. Even the good is relatively is less important, right? So boy, whether it is a boy or a girl or a man or a woman, that all depends on the first word. So first word is more important. So higher weightage will be given to that first word, and that information will be passed across the sentence to predict that last particular word. So here, so these black cells are nothing but these are active cells, while the white ones consider that those as dormant or vice versa. Okay, so this entire LSTM is all about identifying the right memory blocks or the uh, based on the timestamp, which information is important, and based on that, it will predict. Okay, so now this is the link which I will post it in the chat window. You can go through it. It gives a very detailed explanation about this LSTM. So you can read in your leisure. Uh, so let me open this. Okay, so I hope you can see this particular blog. So this is a blog for understanding LSTM. So firstly, they have explained about the recurrent neural networks. LSTM is also comes under recurrent neural network family because it is also capable of processing the sequential data. So in the recurrent neural networks, we have loops, right, where the output of previous layer will be passed to the will become the input to the adjacent layers. Then they have discussed about the problem of long-term dependencies. If you have too many too long sequential data, then it could be a problem. And the problem is that vanishing gradient problem. Okay. Now the LSTM don't have that problem. So then here they have explained about this LSTM network. So layer by layer, they have explained. Okay, so this is something, okay, I would recommend you to go through. So here they have also explained a little bit of mathematics also, what is happening in each layer and how these gates are getting controlled. So here, if you see in this particular network, basically this particular forget gate is responsible for long-term memory, because it is carrying all the information from the first cell block and passing it to all the other cell blocks. Okay, so that particular forget gate is giving that capability of uh, remembering all the events in the past. So that is responsible for long-term memory. Now this output, which is coming out from the previous layer and feeding it to the this current block, this gives a short-term memory, right? What has happened in the recent past. Okay, that is something is getting controlled by this uh, this input gate, right? In the input gate, you are you are taking the output of the previous layer and taking the input of that particular layer or cell block, and you are processing it. Now, the third information which is important is what is happening currently. What has happened in the past over the longer time, that is important. What has happened in the short term, in the recent time period, that is important. And what is happening now, okay, in this current timestamp, that is important. If you process all that information together, you will get a better clarity what may happen tomorrow. Okay, so by understanding, if you understand this network, because it is taking a longer time period, it is taking short time period, and it is also considering the current time period. So if you have such kind of a requirement where all these three information is important to consider to predict the future, then you can go with this LSTM. And now there is another variant to this LSTM, which is called as bidirectional LSTMs. So how this bidirectional LSTM works is in the NLP, in the natural language processing, in the sentence, to understand better, to get a better context, even the information from the right to left is also important for learning purpose. Okay, if you understand what is in a sentence, how to frame the sentence. Okay, if you understand what exactly needs to be conveyed and how it has been conveyed, so in that way, if you train your LSTM, then it can do a better predictions. So that we call as a bidirectional. Now, whatever you have seen, it is basically a unidirectional because the information is passing from left to right. But in the bidirectional, even the context, the the input of the next layer, okay, will also become the input to this current this block also. So some information will be passed from right to left also. So that is called as bidirectional. And that bidirectional primarily we use for NLP, for natural language processing. And even sometimes we also use it for forecasting purposes also to understand how the future values are impacting your current values. So to just to understand, is there any kind of an impact or any kind of a relationship, so that we can able to come up with better predictions. Okay, so if you're seeing that we are getting into very much complicated things now, it is not that easy. Now, things are even much more complicated when you talk about encoders, decoders, transformers. So those are like, too complicated stuff. And now whatever AI and generative AI you are hearing and seeing, right? Those are all built on such complex networks, all these encoders. But to understand all those things, you need to understand these neural networks, because in everywhere you will find these neural networks are the building blocks of all different kinds of networks. Okay, whether it is an encoder network or decoder network, transformers, or these LSTM networks or recurrent neural networks, there would be some other layers on top of our original neural networks, which will help to process that data. But the core would be those neural networks only. And and the whole process of updating the weights, finding out the optimal weights, all depends on those gradient descent. Okay, so these are the fundamental things you need to understand. So for now, as I mentioned, deep learning is going to be much more complicated. So I would stop with this network, because this network is capable of running on unstructured data like text, and is capable of running on structured data, particularly the time series data, because it takes the sequential data. So this one single algorithm is capable of solving different kind of problems. And CNN we have discussed, that is primarily for images. Okay. And the multi-perceptron neural networks that you can use for any kind of structured data. So if you have a good understanding of these three neural networks, I think you are good. You are fine for now, because initially people, and these are the only, and to be frank, these are the only networks we use more often, because with these three networks, we can solve any kind of a problem. But if it is more complicated problem, if the requirement is much more complicated, then probably we may try other neural networks, but most of the things can be done with this. So for example, in the text, if we have to identify the entities, named entity recognition, in short, we call it as NER. So for NER, we have other kind of networks. Okay. People have kind of trained those networks on some standard entities. So for example, if I say Rama is a good boy, okay, if I want to extract the nouns, okay, so Rama, the name will get extracted. If I'm saying Rama is working in Microsoft, okay, so if I want to extract the organization name, the Microsoft will get extracted. So the name of a person, the name of the organization, and if I'm saying the Rama is getting a salary of rupees 10 lakhs per month, if I'm interested to extract only the digital or digits, okay, or the numerical values, then it will pick up those that particular numerical value. So there are certain algorithms which have been trained on such kind of scenario where people have tagged all this information in the data and then train these models. So we can directly use those algorithms or those models to extract these generic entities like name of the person or the name of the organization, name of the city. So whatever the generic entities are there can be extracted. Now, on top of that, if you want to build your own custom solution which can extract very specific keywords, okay, which is meant only to your business, okay, then you have to further go and prepare that data set and then again further train that existing model to adapt to these new entities. So this whole process is called as transfer learning. So transfer learning is something like this. Just think about it. You have certain knowledge about certain things. On top of that, I am giving you some extra learning related to my business. So you will be kind of trained on my particular process. Okay. And typically in any business, it happens, right? If you are hiring somebody, you will take some time to make him suitable for your business or processes. But the whole generic knowledge he will be having is just like you are feeding some more extra knowledge to make it specific to your business. So what you're doing, you're transferring your custom or your specific knowledge related to your business and process to that particular person. So in some of the scenarios, transfer learning is also important because to train the algorithm from the scratch to extract certain information from these texts is going to be a cumbersome process. What you can do, you can consider some pre-built models. Okay, there are multiple pre-built models. We have BERT, we have BART. Okay, so there are so many models which are available. So you can consider those models and you can again further train those models on your specific data set. So that whole process is called as transfer learning. Okay, so further on this, we can discuss more tomorrow because I don't want to bombard with a lot of knowledge, a lot of things today. Okay, so I'll share this particular link with you. Go through it. Okay, go through the recording again. Try to understand, how this and understand it at a high level. If you need some more understanding on it from a mathematics point of view, okay, you can go through it, but it is not required at this moment. Okay, and they will make you understand how these networks can be built in Python and how you can solve a particular problem, by using these networks, okay, when we discuss about the use case. Okay, so here I will stop. So tomorrow I will talk about some other miscellaneous topics. Okay, so I will continue with this transfer learning and then we will have a proper recap of all the algorithms, whatever we have discussed so far. Okay, so if you have any questions on any algorithm, on any model, please feel free to ask. Once we have this revision done, then Vikrant will start the Spark classes. Okay. And I don't want you guys, to have any kind of questions left in your mind related to these topics when you are getting into Spark. And at that time, you have to completely concentrate on the uh, Spark, how the Spark works, how you can build solutions inside Spark. Your focus should be more on that. Okay, so these next 3 days or 2 days, we will have a complete recap of whatever we have discussed so far. All right. So any questions, guys? All right, then, guys, then thank you. Okay, we'll connect tomorrow then. Take care.
Thank you, sir. Thank you.
Thank you.